Okay, we're looking at the Stats and Mechanics second year textbook, and we're doing exercise 8D, which is on differentiating vectors, and we're on question 10, so the last question. Well done if you've made it this far. So it's an exam question, which is good because it means that it tells us how many marks each part of the question is worth, and it's problem solving, so that tells us it's not going to be sort of totally straightforward. There's going to be a bit of thinking to be done. Okay, so I'm given the position vector, and I'm asked, or I'm given information about the speed. Okay, so to get to the speed, I'm going to find the velocity. So before I even worry too much about my exact method, let's just get the velocity vector. So that's going to be the differential of the position vector. So that's going to differentiate. So differentiating this, so 20t is going to differentiate to 20. And 2t cubed is going to differentiate to 6t squared. And then looking at the j vector, so I'm differentiating with respect to t. So it's the t is what I'm differentiating. So I'm going to multiply by that power of 2. Which I don't need brackets for this bit. And the k is just a constant. So that is going to get multiplied by the 2, and the t squared is going to differentiate down to t. And that's my j vector. Okay, so we have seen this method come up before. It was the same, very similar idea to question 8 and question 6. So if you did both of those, it's the same idea. So they tell me what time I'm looking at. So I'm looking when t is 2. So let's sub that in. So when t is 2, that's going to become 20 minus 24. And that is going to become 4k. I think, is that right? Yeah, I think that's right. Okay, so that's going to become 4k j. Okay, and then they're talking about speed. So this comes up a lot. And if it was just a really standard, not a problem-solving question, I would take the velocity. So minus 4 squared, well, the minus will disappear anyway, so I'm not bothered about that. The 4k, I just need to be careful with brackets, because that's going to become 16k squared, not 4k squared, when I lose the brackets. And normally I would just plug those numbers in and come up with the speed. Here they've mixed things up a little bit, so they've given me the speed. And I'm going to then be able to find k. So always with this type of question, I'm going to get rid of the square. So I'm not going to do anything else. So I'm going to square both sides. So that'll cancel the square root from the left-hand side. And I'll square the 16 to get 256. So if I get rid of those brackets, that becomes 16k squared. If I do 256 minus 16, I get 240. So if I then divide by 16, I get k squared is 15, I think. Yeah, I get k squared is 15, if you could see. Okay, and then if I square root that, plus or minus square root of 15, and then if I double check the question, so it says value, so that's telling me I should only get one answer, and there it tells me k is a positive constant, so k is positive root 15. And it doesn't mention rounding, it doesn't mention exact form, so I'm just going to leave it as a surd. Okay, right. So that was worth 6 marks, not bad going. Then I want the acceleration of p at the instant when it's moving parallel to j. Okay, so I'll get the acceleration vector first, and then we'll worry about how we're going to find our value of t. So acceleration is the velocity differentiated, so I can just about still see my velocity vector there. So I won't write it out again. So the I component, the 20 is going to differentiate to nothing, and the 12t squared, sorry, this minus 6t squared is going to differentiate to minus 12t. So that's my I component. And the 2kt is just going to differentiate to 2k. Yeah, if you're differentiating a t term, then you just differentiates down to a constant. Okay, and I know that k is root 15. Okay, So that's my acceleration vector. So now let's think about the problem solving part of this. So I need a value of t to sub in, and they want the instant when it's moving parallel to j. Okay, so my I component is going to the right, and my j component is going straight up. So if they want it to be moving parallel to j, they're talking about when is it moving straight up. Okay, so when is that going to happen? Well, it's going to be when the I component equals 0, and specifically, so it's not moving left or right at all. And when I say I component, it's the I component of the velocity. Okay, because whenever they ask you about the direction it's moving, when it's moving parallel to something, that when you're looking at the actual way it's moving, you're looking at the velocity. If it was asking me sort of when its position was at a certain point, then I'd be looking at the displacement vector or the position vector. Okay, so I'm looking for the I component of the velocity to equal 0. So let's just remind ourselves what velocity was. So velocity was 20 minus 6t squared I plus 2 kt, and k was root 15, although I don't really need this bit of it, I don't think. Okay, so I want the I component to be 0. So there's the I component. So I need the coefficient of that to equal 0. So I need 20 minus 6t squared to equal 0. Okay, so if that equals 0, so if that equals 0, it's not moving right at all. It's not moving left or right at all. It's just going to be moving upwards with a velocity of 2 root 15. So let's add the 6t squared over. So 20 over 6 is t squared. So again, I'm always going to write the positive and negative because when I'm square rooting, because it could be plus or minus, which might not be a meter though. Okay, but obviously we're talking about a time here, so 20 over root 6 is the only one that makes sense. Just be careful that you definitely include the root 6 in that square root. I could work that out or simplify that, but that's just an intermediate step of my working. So the actual question wanted the acceleration at that point. So I just about see it. Yeah, so there's, let's move this whole thing up a little bit. I can't, okay. Right, so what's going on there? Right, no. Okay, so let's just scroll up a little bit. Right, so there's my acceleration. Okay, so what is that going to be when t is root 20 over 6? So it's going to be minus 12 times the square root of 20 over 6, and I will tidy that up. And then the j component wasn't dependent on t anyway, so that was just 2. That's constant of 2 root 15. So I'm going to be lazy and just stick that third into the calculator. So again, just be careful. It's the square root of 20 over 6, all inside the square root. Okay, so that's giving me minus 4 root 30 I plus 2 root 15 j. We'll include the units just in case. And it doesn't mention exact form or rounding it, so I think I'm just going to leave that in exact form. It's really the neatest way to give it. And I'm just going to double check our answers. So yeah, we've got the root 15. Just double check. Acceleration, yeah, minus 40 root 30 plus 2 root 15, lovely.